Hey kids, it's Mrs. Compton. We're getting ready to start your 4th grade chapter 3 review, which begins on page 135. And I just want to remind you, I'm not going to do every single question as I go through this review. I've picked out some of the ones that might be tricky, and we're going to focus on those. Okay, so the first one says, explain how to find 40 times 50 using mental math. All right, so the key is not only do you have to know what the answer is, but you have to be able to explain it. So maybe some of you might think about it as 4 times 10 is 40 and 5 times 10 is 50. Or maybe you even thought about it as 4 tens and 5 tens, right? So a lot of us start thinking about our basic fact. So we know 4 times 5 equals 20. Now, maybe you're actually thinking about the 4 tens as 40 times 5 tens. Maybe you're doing it like that. Now, 40 times 5 tens would be equal to what? Let's see. 40 times 5 would be 200, but we still have the 10, so 200 tens. Now, that means I have to multiply this by 200 as well. So the answer then becomes 2,000. Some of you are like, wait, that's just way harder than doing 4 times 5 is 20, and then I add 2 place values, which is true. You can use that method, but you have to be able to explain what you're doing, right? Okay, one other thing that you might look at is 4 times 5. I'll use a different color for this strategy. 4 times 5 is 20, and 10 times 10 times 10 right here, is 100. You guys probably know that, right? And 20 times 100 equals 2,000. So maybe you would solve it that way. So we got the same product both ways. We need to just be able to explain what we're doing, right? And we're not adding zeros, we're adding place values. All right, up next, we're skipping number 2. You've got that on your own. We're heading on to number 3 on page 136. It says for numbers 3a through 3c, select yes or no to show if the answer is correct. All right, here's 3a. 35 times 10 equals 350. All right, so 35, we're adding a place value because we're going times 10. The answer to that is yes, it does equal 350. 350, I should say. Okay, next up, B. 19 times 20 equals 380. All right, so maybe you're not sure about this one, or maybe you're thinking about it as 20 times 20 equals 400, and then you're like, oh, I added an extra group of 20 on there, so I have to take it off. So then it would be 380. So maybe you're starting to suspect that it's a yes, or maybe you're even thinking about 19 times 2, and you're like, well, I've got that one down, so I'm going to use that basic fact and then add a place value, or times 10. Maybe you're doing that. Or maybe you do 10 times 20, 9 times 20. Either way we come out, it does equal 380. So the answer to that one is yes. All right, next up, we've got C. 12 times 100 equals 120. All right, so we've got 12 times 10 is 120. So 12 times 100 cannot equal 120. It has to equal 1,200. So this one gets a no. All right. Have you ever heard people actually say 12 times 100 is the same as 1,200? Because we're actually using 12 hundreds. So you might actually think about that too. Okay, and we've got D. 70 times 100 equals 7,000. All right, so we're going to go with 70 times 100, also known as 70 hundreds. And then you could also use your basic fact of 7 times 1 is 7. And then you're adding on those 3 place values, right? So this one is a yes. Okay. All right, let's check out E, see what it is. Yes or no? 28 times 30 equals 2,100. All right, so let's check this one out. How would you do this one? I think what I would do is separate this out into a 10 times 3 for myself. You get to do whatever you want. This is what I'm thinking. And then I'm going to do, I think I'll do 28 times 10. 28 times 10. I'll do that part first. I'll put it in parentheses just to help guide my eyeballs. Plus, or actually I could just do times 3. Okay, I kind of like that. All right, so that's what I'm going to do to see if it actually equals 2,100. So 28 times 10 equals 280. And now I have to multiply that by 3. Okay, so I think I'm going to do 200 times 3 is 600. And 8, let's see, so let me move this around a little bit. 200, I'm going to move it right here. So I have a little more room. All right, so we've got 200 times 3 equals 600. And then we've got 80 times 3 equals 240. And we add those together, and our answer is actually 840. So that's a negative for that one. That's a no. Because when we add our partial products, we don't get 2,100. We get 840. So that is one that we cannot mark as a yes. All right, here we go. Number 5, which would provide a reasonable estimate for each product? Okay, write the estimate beside the product. An estimate may be used more than once. Okay, so these are our choices. So these are what we get to choose from for our answers, okay? So underneath the shade, I have our options. So we've got 23 times 38. So which of these would provide a reasonable estimate? Actually, let's keep those covered for a sec. So 23 times 38. Do you think 50 times 20 would be reasonable? Or 25 times 40? Or 30 times 30? So let's see. Well, 23 is pretty close to 25. And 38 is pretty close to 40. So I would say that this one could fit in here. Does that make sense to you? Would that give us a reasonable estimate? We're using compatible numbers, right? Okay, let's slide over to this one, 46 times 18. So 46 is close to 50, and 18 is close to 20. They would round to 50 and 20, right? So I think this one would make a good estimate. All right, let's reveal the next ones. So we've got 31 times 32. This would round to 30. This would round to 30. So I'm going to go with this one. And last up, we've got 39 times 21. So we're actually going to need to use one of these more than once, right? It says an estimate may be used more than once. No biggie. So 39 would round to 40, and 21 would round to 20, but I don't see that as an option. So now I've got to find one that looks good to me, but isn't exactly on there. So let's see. I'm going to still round this one to 40 because it's so close. And I'm going to take a peek. I see that there's a 40 here. And that's the only 40 there is. And then 30, let's see, 21 is fairly close to 25. So it would give us a reasonable estimate. So I think I'm going to choose this one. Makes sense to me. All right, moving on. Number 6. We've got baseball going on, and you know what? If your neighborhood was anything like my neighborhood, when the Dodgers won the World Series, there was a big celebration. Go Dodgers! All right, number 6 says there are 26 baseball teams in the league. Each team has 18 players. Okay, so stop to imagine that. We've got 26 baseball teams in a league. So we've got Dodgers, we've got Giants, we've got all kinds of teams, right? And each team has 18 players. Okay, so get that in your mind. So 18 players. Write a number sentence that will provide a reasonable estimate for the number of players in the league. Okay, so we're going for a reasonable estimate now. So we've got 26 teams. Each team has 18 players. And then we're writing a number sentence. That doesn't mean with words. That means with numbers. Number sentence that will provide a reasonable estimate. Okay. And then we have to explain. You're going to do that part. I'm not going to do all the writing to explain. You'll do that for yourself. All right. So what are you thinking? I'm looking at our numbers. 26 times 18 is the real thing that a question or real numbers that would provide us the exact. You know what? I don't like my word real. I'm going to change it to exact. I'm going to be more precise with my words there. Okay. Now we've got to pick out some numbers. So I like the number 25. It's compatible to 26, and you can think in quarters when you get a 25. So I think I'm going to do change my 26 to a 25. Compatible numbers. And I'm going to change my 18 to a 20 because 18 rounds to 20. And then it's not going to be exact anymore. It's going to be an estimate. Now there's like a fancy squiggly equal sign for estimate. I don't see where it is. I'm just going to write with my tool. I'm going to write my little fancy squigglies. This symbol means estimate, or there's been an estimation that's happened, right? Okay, so 25 times 20. Well, let's think. I can use quarters to help me. 25 cents times 2. So if I had 2 quarters, that would be 50. But I have to make sure I do that times 10. So that is going to give me the estimate of 500. 25 times 20 is 500. Now you could have done anything. You could have done something else too. You could have done 30 and 20. It just depends. You have to create the estimate. And then you also need to make sure you write to explain. I'm not doing that part for you. You make sure you write to explain how you know. Okay? All right. Moving on. Number 7. The model shows 48 times 37. Write the partial products. Okay, so in this case, we've got one of my favorite strategies. We're showing 48 times 37. So 48 was broken up right here into a 40 and an 8. So 40 plus 8 still makes that 48, right? And 37 was broken into a 30 and a 7. And 37 or 30 plus 7 makes that 37, right? Okay, so now we're going to do 30 times 40 for this one right here. Whoa, we want it to go in the box. 30 times 40 equals, well, I know 3 times 4 is 12, and I'm adding 2 place values, so it must be 1,200. All right, now we're going to do 7 times 40. And 7 times 4 is 28. And then I'm going to add that place value, so 280 for that one. And then over here, I'm going to do 30 times 8. And I know 3 times 8 is 24, and I'm going to add that place value. And whoa, Nelly, that's way too big. Let's see if we shrink that down. Whoa, got it. Made it fit. Okay, and now we've got our basic fact, 7 times 8, although 7s and 8s sometimes elude people. It is 56, but it's a hard fact to memorize. Okay, so it says write the partial products. So did we do that? That's a part of the product. This is a part of the product. This is a part of the product. And so is that. Does it say we have to solve? No, it just says write the partial product. So guess what? We're done. All right, page 137. Jess made this model to find the product 32 times 17. Her model is, ooh, it's incorrect. It says so right here. Yowza. Jess needs to check her work. Okay, so what did she do wrong? We've got to find out. So she did 32, split it into a 30 and a 2, and she split 17 into a 10 and a 7. That looks right to me, right? Because you could add that together, and that's 17. You can add that together, and that's 32. So whatever's wrong must be inside here. So let's check it out. So our first move would be 30 times 10. Well, I think we've discovered it. 30 times 10 is not 40. What is 40? 30 plus 10 is 40. Let's see if she makes an addition error on the next one. Oh, man. 30 times 7 is not 37. 30 times 7 is 210. So we know that Jess accidentally added instead of multiplying. So we know that she accidentally added. Bummer, Jess. Gotta check your work. All right, so part B is related to this. It says redraw the model so that it correctly shows 32 times 17. All right, so we already know that let's go back here for a second. She got the 10 and the 7, the 30 and the 2 correct, right? So we may as well just put those back on. That's good to go. 10 plus 7, and then 30 plus 2. That was set up correctly. But we've got to make sure that we get the correct partial products inside. So we've got 30 times 10 is, say it if you know it, 30 times 10 equals 300. And then 30 times 7 equals, think about it, 210. And then 10 times 2 equals 20. And 7 times 2 equals 14. Okay. Does it say we have to do anything else, or do we just have to redraw the model so that it correctly shows 32 times 17? And it looks like this is all we're required to do for this one. So you know what's coming, right? Part C. Part C, what's the actual product of 32 times 17? Good news, kids, we're almost done because we've got our partial products. So all we need to do is add 300 plus 210 plus 20 plus 14. All right. 300 plus 200 is 500, plus 10 more is 510, plus 20 is 530, plus another 10 is 540, plus 4 is 544. So her answer should have been, and the correct answer is 544. All right, kids, we made it. We're on to number 9 with Tatum. And Tatum wants to use partial products to find 15 times 32. Write the numbers in the boxes to show 15 times 32. All right, remember, we can just break up our numbers. So we've got 10 plus 5 makes 15. We've got 30 plus 2 makes 32. Remember this from way back when, like when you're in first grade? It comes back to haunt us. Even in 4th and 5th grades, we're still using the ideas of number bonds and breaking apart numbers, right? Okay, so we need to make partial products. So we need to multiply. You know what? I actually like the idea of setting up a little rectangular area model so that I can do 32 like this. Whoa, somebody got a little crazy with the line. And then 15 set up like this. I think I like that idea because honestly, it really helps me to see what I need to multiply together. So I need to do 30 times 10, right? That would go here. So I can do that here. 30 times 10. All right, we've got that part done. And then we also need to do 2 times 10. So we're going to add it to 2 times 10. That would be this part here. And now let's do 30 times 5. 30 times 5. Did you guys just notice something? I did. I need another one. I need to make some more because we still have another partial product left to go, right? So we also need to add, let's get back. We also need to add plus this piece, right? We can't leave that one out. So plus 2 times 5. Now you should have had that in your book. Your book was all set up with that correctly. I just forgot mine. Okay, so this is one option. You can also have these numbers like 30 and 10 could be over here and 2 and 10 could be over here. But the pairings have to stay together in the same group. So these stay together and these stay together and so on. Okay, so if you get a partial product question on your assessment, and you don't see an area model like this, you can always draw an area model. This really helped me. It actually helped me see that I had an error that I needed to add another step on here. So I missed that 2 times 5. The area model helped me catch it. All right, moving on. Number 11. Mrs. Jones places 3 orders for school t-shirts. Each order has 16 boxes of shirts, and each box holds 17 shirts. How many t-shirts does Mrs. Jones order? Use partial products to help you. Okay, that's a lot of information. So right now, I want everybody to stop and read it back to themselves and make the picture in your head. Okay, did you get that picture down? Mrs. Jones places 3 orders for school t-shirts. Each order, so it's almost like she does 3 orders, and each order has 16 boxes times 17 shirts per box. Okay, so she does 3 of these, right? So we can actually see her 3 orders. Now we have to figure out how many t-shirts does Mrs. Jones order. So you could solve this in different ways, right? I like to kind of think about the picture and then solve with whatever picture's in my head with a strategy that makes sense. So what do you think? What would you do? I don't know. I'm thinking I'm picking out my strategy. 17 times 16, I could do that, or 16 times 17 and then do it 3 times. Could do that. What do you guys think? I think I'm going to do that. I'm going to shrinky dink this down so that I have more space. Okay. So 16 times 17. I am definitely going to draw an area model. So 16. Yeah, I'm going to make that a 10 and a 6, I think. And 17 here. 10 plus 7 is 17. And 10 plus 6 is 60. All right, now we go. 10 times 10 is 100. 10 times 6 is 60. 7 times 10 is 70. And 7 times 6, that's a fact that kids seem to forget a lot. 7 times 6 is... Okay, now we need to add up our partial products. So 100 plus... Actually, you know what? I just saw this. This plus this makes 102. Woohoo! So that's going to actually make it easier for me to add on. So I'm finding friendlies first. So 100 plus 102 is 202. Plus 7 plus 7D, sorry, Speckles is saying hi, is 272. Now, the thing is here, kids, that only represents one box. Speckles, would you like a t-shirt from the box? Is that what you're saying over here? Is that what you want? She's very picky about her clothing. Okay, so this only represents one box. So we have to do it how many times? We've got to do that 3 times. So there we go. 272 times 3. Speckles, if I get you a t-shirt, will you be quiet? So we're solving that. So maybe you would do 200 times 3 is 600. And 70 times 3 is 210. And 2 times 3 is 6. And we add them all up together, and we get 816. Right? So all together, I'm writing it over here because I ran out of room. 816 after we add all of our partial products. That should tell us about all 3 boxes. Now, because Speckles was not behaving herself, I'm going to make sure I got it right. So check my work. Okay, 816 shirts. Done. Go. All right, write the unknown digits. Use each digit exactly once. These are our choices. Okay, when I first looked at this, I was like, wait, what? And then I was like, oh, I could do this. Oh. Now we've got both dogs barking. That's Chip in the background, too. Now Chip wants to join in the party. All right, so 46 times 93. Well, the largest number here is this number. So it's probably going to be representing our 40 times our 90, right? What is 40 times 90? Well, 40 times 90 is 3,600 because 4 times 9 is 36. All right, and then we have our basic fact, and then we add our 2 place values. All right, now this one right here would be what? So we're kind of like trying to figure it out. So would it be 9 times 6? I think it actually would be. So 9 times 6, actually it's 9D times 6 is 540. Because we know the basic fact, 9 times 6 is 54. All right, up next, we've got to figure it out. Blank 20. So, aha, I see. 40 times 3 equals 120. So that's got to be it. And then 6 times 3, I think, is our last thing. 6 times 3 is 18. So that's got to be 18. Okay, and now we're going to add them all up. 8. 4 plus 2 plus 1, 4, 5, 6, 7. Checks out right there. 5 plus 1 is 6. 6 plus 6 is 12. So that would be a 2 there. Okay, so let's check, make sure. We've got a 6 here. Use that. A 4 here. Use that. A 1. An 8. And a 2. All right, I'm feeling good. I think we got that one. All right, number 16. Here we go. What page are we on? I don't even know anymore. We've done so much work. So number 16 is on page 139. All right. Select another way to show 25 times 18. And oh man, we're going to get lots of options. But first, what I want to think about is just the place value. So this is 20. And this is 5, right? If we add them. And this is 10 plus 8. It just helps me to plan out and just think about it before I go look at all the choices, because sometimes I get overwhelmed when I look at all the choices on there. I'm like, I don't know. All right, so our first one is 20 times 10. So we can see 20 times 10, 20 times 8, 5 times 10, 5 times 8. Okay, that actually checked out pretty nicely. Don't forget, you can also draw your area model. So we could do a 20 and a 5 if that helps you, which clearly you saw it helps me. Even teachers make mistakes or notice new things, right? So we want to make sure we're setting ourselves up for success. Okay, so this one checks out as a yes. Okay, next step. 25 times 20. Okay, so if we put these two back together, we'd have a 25 times 20? 25 times 20. I don't think this is looking so hot so far for this one. What do you guys think? Because it says 25 times 20, 25 times 5. No, this one just can't be it. It's all kinds of confused. Okay, so up next, 20 times 18. Okay, so that's if we put this back together, the 18, we'd have 20 times 18 right here, right? So that part is there. And then 5 times 10, well, that's still that part. And then 5 times 8, and that's that part. So this one is actually a yes. All right, sweet. Okay, next up. 25 times 10. Okay, so that's if we put these back together, we'd have 25 times 10. I'm gonna switch out my color. So that would be this piece. So that checks out. Now we have 25 times 8. That would be this piece. So that's a yes. Okay, that sounds good to me. Moving on. 25 times 20 plus 25 times 5. Well, guys, that would give us something more than 25 times 18. So that one is a no-go. All right, we're moving on. We've got number 18. There are 3 new seats in each row in a school auditorium. There are 15 rows in the auditorium. Each new seat, not you seat, each new seat costs $74. What is the cost for the new seats? Explain how you found your answer. All right, now remember, I'm not going to do the writing to explain. You've got to do that. So there are 3 new seats in each row in a school auditorium. All right, so 3 new seats in each row. There are 15 rows, and each new seat costs $74. Okay, what's the cost for the new seats? We can do this, you guys. All right, so we've got 3 new seats in each of the 15 rows. All right, well, 3 times 15, you probably know, is the same as 3 times 10 plus 3 times 5, which equals 45. Now, that tells us the number is the number of new seats. So, does that tell us our answer? Not yet. Each new seat costs $74. So now we have to do 45 new seats times $74. And that will give us our answer. Okay, so how are you going to do this? How are you going to break up 45 times 74? If you have figured it out yet, I love area models, so that's what I'm doing. So here I go. I'm going to make this one up top 74, and I'm going to make this one on the side 45, and I'm just going to type my numbers in. 40, wrong, 70 plus 4, 40 plus 5. All right, I'm going to use my partial products because I'm learning my basic facts. It just makes my life easier. 4 times 7 is 28. And I know I need to add 2 place values, so 2,800. 5 times 70 is, well, 5 times 7 is 35. And 1 more place value. 4 times 4 is 16. So 40 times 4 is 160. And 5 times 4 is just plain old 20. All right, here we go. It's time. We've got to add up our, what are these called? Partial products. We've got to add up our partial products. So I think I'm going to do, I'm always trying to find a way to make it a little easier for myself. So I think I'm just going to do these two first. So 2,800 plus 350. 2,800 plus 200 would give me 3,000. So that would be 3,150 for this part. And this is 180 over here. So now I'm going to do 3,150 plus 180. And I'm going to do that, and I'm going to call it a day. Because that, remember, is going to tell us our answer. So here we go. Oh, I need my line. Hello. There we go. And I'm adding plus. Okay, back at it again. 0 plus 0, 0. 5 plus 8, 13. Carry a 1. 1 plus 1 plus 1, 3. And 3 plus nothing, 3. So that makes 3,330. And we've got to put on the dollar sign because that's our answer. So $3,330. So I'm going to change that. Okay, last up. This is the last one we're doing together, kids. You've heard it all. You've heard barking. You've heard me talking. You've heard my neighbors, I'm sure. All right, so we've got number 19. Ray and Ella helped move their school library to a new building. Okay, we can probably imagine that because we did pack up our schools. Ray packed 27 boxes with 25 books in each box. All right, go Ray. And Ella packed 23 boxes with 30 books in each box. How many more books did Ella pack? Okay, so Ella, we know from the question here that Ella is going to pack more boxes. So I'm going to start with her number. So 23 boxes with 30 books in each box. And then I want to find out how many more she packed than Ray. And Ray did 27 boxes with 25 books per box. And that will equal our answer. Okay. Ooh, and it says show your work. And we're going to. 23 times 30. All right, kids. I'm going to do 23 times 3 as my basic fact. And then I'm going to use that. Actually, I think I'm going to do it times 10 first. I like that. Okay, so 23 times 10 is 230. I could have done 3 first. Huh. Doesn't really matter, I guess. So this is Ella over here. And then 230 times 3. Oh, I also want to make sure I put times there. Oh my gosh. 230 times 3 is, well, 2 times 3 is 6. So 200 times 3 is 600. 30 times 3 is 90. So 690. All right. So this is Ella's total, right? So I'm going to erase that. And I'm going to put 600. I'm going to put an equal sign for Ella, 690. Now, remember, we are subtracting off whatever Ray got. So this is Ella. This is Ray. And Ray is going to do 27 times 25. Maybe you want to do an area model for that one. It should almost be a square. I kind of messed that up a little bit, but that's okay. So 25 times 27. 20 times 20 is 400. 20 times 5 is 20 times 7 is 7 times 5 is, okay, add them all up. 400 plus 100 is 500. 500 plus 100 is 600. 600 plus 40 is 640. 640 plus 35 is 675. Okay, so minus, Ray packed 675 boxes. So we're going to now do 690 minus 675. And I know, well, I actually know 75 plus 10 is 85, plus 5 more is 90. So 690 minus 675 has got to be 15. So Ella wins with book packing by 15 books. All right, kids, make sure when you are doing your assessment that you are thinking about what the problem looks like. You're stopping, you're reading more than one time, and you are using the very important area models if they help you. All right, kids, see you next time. Bye.